Hello, my name is Ian Moriarty. I'm going to be walking you through my final project, WeatherDBd3 for csci E63 Big Data Analytics. So, what is WeatherDBd3? I like to think of it as an exploration of weather data, a way for anyone to quickly see and examine historical weather data. We're going to do this through a couple of different methods, the final being allowing people to see their weather data quickly and easily from really any device that has a web browser on it. But in order to get the weather data, that brings us to the Integrated Surface Database, or otherwise known as the ISD. The ISD is roughly 20,000 active stations worldwide, and there are hourly recordings of many different data points, some of them including air temperature, dew point temperature, pressure, wind direction, wind speed rate, cloud coverage, and precipitation. And some of the readings actually go back to 1901, so it's a pretty extensive data set. And you can imagine the amount of data this actually generates when all these stations, all 20,000 of them, are sending data every hour with so many data points. The numbers actually become quite mind-boggling. So how available is ISD? Well, actually, you'd be happy to know. Actually, it's open to anyone. So you just navigate to NOAA's FTP server, and you're greeted with a really user-friendly page. Well, actually, you're greeted with this. This is just an FTP directory of all of these files, which are gzipped together in what seems to be a pretty disorganized fashion. Actually, there is organization here, but it's definitely not a user-friendly experience. So yeah, some of the problems with what we just saw is definitely, like I just mentioned, is not user-friendly. It shows nothing about the underlying data that the user is about to see and what it actually means to them. There's very few details about what actually these files contain. I mean, this directory listing just has, I mean, it almost looks like random data. It's not, but we'll get into that in a second. And there actually is very little documentation on what this data asset actually contains. There's a few text documents, but it's not a very well documented data set. So in order to fix this problem, we need to organize this data into a database, sort and parse it in different ways. By putting it in a database, we'll actually get quite a bit of structure from that, and then we can actually do quite a few different things with it. Also, it'd be nice to analyze the geographical aspects of this data. Since all these are coming from stations, and these stations are located somewhere in the world, we can draw some conclusions like that about geography. I'd like to make this data set accessible, and also, to tie this back to the user, actually make it relevant for the user. So I started with a backend stack of Python and MongoDB. Python is a great language to just get quick scripts running, and Mongo is a pretty easy to work with database. It's a document store, which it's pretty quick to get up and running on your system. And so I started with one application, you can think of it as, that's called ISD Parser. And this is a couple Python scripts that actually will go through this database and parse it and actually organize it and insert them into a Mongo database. The usage is really simple. You run data loader, you give it the history file, which is actually all the station locations, and you give it a folder. The folder contains all the recordings for that year for all stations. So then it'll go through the folder, look up what station's actually recording it from the file that we fed it before, and we'll add that extra metadata onto that information, which is missing otherwise. It's a multi-process Python script, so I found the best performance actually happens when you run about the same amount of cores your CPU has, that many Python processes. So there's actually a parameter you can set to how many processes you want to spin up when you start parsing this data. And then there's another script actually called station loader, which is basically data loader but simplified, which is just loads station data, geography, information about each station, elevation, a couple other facts about the station. This is a separate collection. So this is actually what a station document looks like. We can see ID is something that Mongo puts on it. Location is a standard called GeoJSON, where we set it as a point, and the coordinates we give it, longitude, latitude, elevation, those are meters above sea level, what state it's located in, if it has a state, what country, and then this is actually the entry for Logan International Airport. So let's talk about the numbers. So we have two collections in our Mongo database, which equates to 31,944 stations, and we have 544,014 documents. Each document contains a year of weather data, which is 47 billion observations and then each observation has about 5 measurements. So that's about 238 billion measurements, individual measurements of different weather data. That could be air pressure, air temperature, pressure, or something else. Station data, all 31,000 stations, is about 22 megabytes on the disk, and weather data is 477 gigabytes. And like I said, I want to make this accessible to the user, so using a front-end stack, which is Twitter Bootstrap for just markup and CSS, and D3, which is a charting and a document language. It's a pretty extensive library to make dynamic documents, as they call them, which are data-driven documents. And NVD3, which is attempts to be a standardization of charting built on top of D3. Like I said, Bootstrap for layout, D3 for maps, which I'll show you in a second, and NVD3 for charting in the front end. So first I'm going to show you a demo of the back end, and then I'll show you a demo of the front end code. So exit. Okay, so let's clear this real quick. So first we're going to connect to our Mongo instance. This is actually running on an iMac that I have with 16 gigabytes of memory. So let's see. So first we're going to say let's use station. So let's make sure this is actually legitimate. So okay, here we can see we have those 31,944 stations loaded into the database. So what we can actually do here is first we can just find one. Let's see what a station looks like, a random station. So this is what a random station looks like. You can see some fields, if they don't have an entry, they just put 9s, and then it has a geographic location. Let's go but what's cool is since we actually built an index on top of the longitude and latitude points, we can actually find stations that are closest to us. So let's see. I think I have a built-in query that I've used before. Okay, so this is actually not formatted very well, but what this is basically telling us is Boston is about -71, 11 longitude, 4237 latitude, which is right here, which is a query we can put in for coordinates, and then we're going to ask for 10,000 meters, which is 10 kilometers around the city, and see what are the closest stations to us. So we can see we get a couple different stations, and you can see Boston City has one. We can also see Boston Logan again. So that's kind of cool. So let's go over to our weather database now. Use weather. So now we're in the weather database. We can actually do another count and see how many we have in here. Okay, so yeah, we can see we have 544,014 different documents. So we actually let's find a random one now. See what it actually looks like. This could really spam the screen, so I'll make this full screen. Actually, this isn't so bad. So we got lucky here. We only have one. We only have a document with one. So let's find an old station. Let's go find one in year 1901. I chose an old year because these usually have a lot less information. And we can say, okay, well, I guess I was wrong. This one actually has quite a few, pretty extensive data set. We can see a lot of data, a lot of different data points for the weather being printed here. So let's see. So that's really it for the back-end code. Let's go into the weather site. So this is what a user will see in the day when they actually use WeatherDBd3. It's really intended to be a web app. So when the user is greeted, they see there's three main options they can choose, which are maps, charts, and numbers. Numbers is something that's just going to tell them how much is in the data set and show them how big the data actually is. Charts are just different charts, and I'll show you in a second. And then maps are kind of interesting. So let's go to maps first. So we'll see. So every single point here is a different weather station in the United States. So this map actually supports scaling, so we can actually click on Massachusetts, and we can see each dot here representing a different weather station. We can see a couple around Boston. We actually probably can see Logan right there. Okay, so let's go back and let's go to another chart that's generated. This is all D3 stations with age. So this is a different data visualization that is going to show us how old and the clustering of the stations. So the darker the hexagon, the older the station is. Like I said, back to 1901, and the brighter white it is actually how the newer station. And let's go to world. So this is actually a really impressive data visualization, I think. This is all the separate weather stations in the entire world. It's just the same map that we saw before, just blown up to a global scale. And again, weather stations with age, same thing. It's showing the age with the same scale. 1901 being the oldest stations. And then let's go to charts, since this is weather data after all. And I pre-built some of these charts, which as you can see here, Logan. This is 2013 weather data for Logan every single day of the year in 2013, with blue being min temperatures, and for that day, red being maximum temperatures for that day. And we can also, since this is NVD3, we can actually turn off different data points, turn on different data points. So I just turned off max temps, so now you're just seeing the mins for the year, and now I just turned off min temps, so now you're seeing all the maxes for the year. And then the last data point that I'm going to show you is this. This is a lot of weather data. This is 1950 to 2013 for Logan Airport. So it's not really visible initially, but once you start filtering down months, you can actually, let's do August and September. So we'll see since 1950, the median temperature in August and September at Logan Airport. So that's kind of a fun one. And then let's go to numbers. So this is what I showed in the slide before, which is trying to show the user just how much data is actually here. Like I said, 2 collections, 31,944 stations, 544,014 documents, about 47 billion observations, and about 240 billion measurements. Disk usage, 22 megabytes, 477 gigabytes of weather data, and the computer that I ran this on, which actually became somewhat problematic, was an iMac with only 16 gigabytes of RAM. MongoDB really likes to get a lot of RAM, and that was actually somewhat of an issue. And I average about 10 inserts per second. Initially, I was having much higher inserts per second, but as the database became large, that number drops substantially. It took about 24 hours to load all the data into the database at the end of the day. WeatherDB here is just a quick overview of what WeatherDB is, one-pager if you have it, and then I have 2 links down here to the source code, both on GitHub, both for the web and for ISD parser. ISD, this is the web. This is just the website we just saw. All the source code is documented with a git check-in above it. How to set it up locally. and then ISD parser is its own repository, which is just all different different ways to set it up, how to run it, how to download it. It's a pretty substantial data set. It would take probably about 24 hours to download just from the FTP pairs and node, but that's all in there. So thanks for watching. I hope you enjoy. This link will stay active for as long as I can keep the website running. So thanks a lot. Bye.